Hello everyone, this is video number 9, part 4, chapter machine, and today we shall discuss the topic pulley. First of all, what is pulley is? Pulley. What is pulley is? It is a piece of equipment. It is a piece of equipment consisting of a wheel and a rope that is used for lifting heavy things. Once again, it is a piece of equipment consisting of a wheel and a rope that is used for lifting heavy things. Now, types of pulley. The first one is single fixed pulley. The second is single movable pulley. So types of pulley, one is single fixed pulley and another is single movable pulley. Now I will show you one diagram. Just see, this is a diagram of single fixed pulley. So any pulley, first of all, it consists of frame. This is called frame and it is made up of iron. And then axle. This is called axle, means this is the axis of rotation. And this is the grooved rim. This is the grooved rim on which this inextensible string or rope, once again, on which this inextensible string or rope is passed over. So all the pulley consist of whatever the pulley is, either it's a single or movable pulley, it consists of frame, axle, inextensible string and this grooved rim. This is grooved rim. Now first of all, we shall start with single fixed pulley. We will start with single fixed pulley. First of all, we will take single fixed pulley. Now in this diagram, single fixed pulley, a pulley which has its axis of rotation fixed, whose axis of rotation is fixed, is called a fixed pulley, single fixed pulley. Got it? What is single fixed pulley? A pulley which has its axis of rotation fixed is called fixed pulley. Now, the mechanical advantage mechanical state पे I am coming to the point. Mechanical advantage of a single fixed pulley. As we know that mechanical advantage is load upon effort. As we know that mechanical advantage is equal to load upon effort. Now we will try to understand this diagram. First of all, students, this is the load. This is load, and load always acts vertically downward direction. Means the weight of this solid body is acting vertically downward direction. So in order to balance the weight or the of this load, the force of tension which is there in the string, balance it. Means the load is acting vertically downward direction, and the force of tension which is there in the string, it is acting vertically upward direction in order to balance the load. Got it? Huh? Now on the other side, the effort is being applied in vertically downward direction. When the effort will apply vertically downward direction, this string will move like this, and the load will move in the upward directions. Once again, you are applying a force here in the vertically downward direction, and when you will pull the string downward, so automatically this load will move in the upward direction. Got it? Na? So in this case, the load is balanced by tension, and here on the other side, the effort has to overcome the force of tension, because tension is acting vertically upward direction and the effort is applied in the vertically downward directions. So when you will apply the efforts in the vertically downward direction, it means you have to overcome the force of tension which is there in the string. First of all, student, here it is written load is taken 10 kgf or 98 Newton. And here it is written effort applied, that is 98 Newton. First of all, it is a case of idle pulley. It is a case of idle pulley. It means we are ignoring the force of friction between the rope and the grooved rim. Once again, idle case means we are ignoring the force of friction between the string and the grooved rim. Getting? So we are just discussing the idle case of this machine or pulley. So here it is taken, load is taken 10 kgf, because in the absence of any other force, we are just taking force of gravity, and we know that 1 kgf, that is equal to 9.8 Newton. 1 kgf is equal to 9.8 Newton. So 10 kgf will be equal to what? 98 Newton. So here the load is taken as 98 Newton. So in idle case, the effort will also be equal to 98 Newton, because it is an case of idle. It is an idle case of pulley. Otherwise, if we will not ignore the force of friction between the inextensible string and the rim, so effort apply will be more. Here we have to apply more effort. What we are doing, we are just ignoring the force of friction between the string and the surface of the rim of the pulley. So just mind it, we are just discussing the idle case of the pulley. Now I am coming to here mechanical advantage, that is equal to load upon effort. So just see that load, that is equal to tension. Clear now? Because the load is balanced by tension. And on the other hand, effort, here it is effort, you are applying effort vertically downward direction. So effort, that is equal to force of tension. So now you can put this in mechanical advantage. So mechanical advantage, that is equal to load upon effort, and load is equal to tension, and effort is equal to tension. Tension and tension get cancelled, so mechanical advantage is equal to 1. So in this arrangement there is no gain in the mechanical advantage. Clear? Now come to the next, velocity ratio. Velocity ratio of a single fixed pulley. Velocity ratio. Velocity ratio, that is equal to displacement of effort upon displacement of load. Just see to it, students. This is important point. If the point of application of effort E moves a distance d downwards, distance d downwards, so that much distance will be moved by the load in the upward direction. That will also be d. As much as the string moves downward, that much load distance will move by the load in the upward direction. Once again, if the point of application of effort moves a distance d downwards, the load also move the same distance d upward direction. So you can write here, if the displacement of effort, that is equal to d, so displacement of load, that is also equal to d. D and d get cancelled. This is equal to 1. So the mechanical advantage of single fixed pulley, that is equal to 1, and velocity ratio, that is also equal to 1. Now the third is efficiency, that is equal to mechanical advantage into velocity ratio. So this is equal to what? Mechanical advantage is 1, velocity ratio is also upon 1. This is equal to 1, or you can say that it is 100%. Efficiency is 100%, and it is only in case of idle case. And if it is not idle case, the efficiency can't be 100%. Now the next is, we can say that a fixed pulley, we can say that when the mechanical advantage is equal to 1, so that type of pulley or fixed pulley is used to change the direction of effort. Like you can take a case of fetching of water from the well. Once again, you can take an example of this single movable pulley, fetching of water from the well. So we are just changing the direction of the force applied by pulling the string downward direction. Now move to the next. Next is single movable pulley. Next is single movable pulley. Now students, in this case, single fixed pulley, the axis of rotation is fixed. Single movable pulley means the axis of rotation is not fixed. It means that the axis of rotation is movable. Once again, Single fixed pulley axis rotation is fixed, whereas single movable pulley the axis of rotation is not fixed. So this is a diagram of single movable pulley. Just see it. This is the rigid support and this is the hook on which this pulley is being suspended. Now here in this case, just see that the string is passed over like this in the upward direction. So in this case, just see that the whole arrangement, when the effort is applied upward direction, the whole arrangement means not only the load but also the pulley will move in the upward direction. This is the main difference between the fixed pulley and a movable pulley. Once again students, when you will apply effort in the upward direction, not only this load but also this pulley will move in the upward direction. Just see that again, the load that is acting vertically downward direction and this load along with this pulley, it is balanced by two tensions. This tension T and here tension T. It is just like this, upar in the upward directions. Getting? It is just like this. Here it is just like this. So the load is balanced by two tension in the upward direction. In this case, single fixed pulley. So again, the mechanical advantage of a fixed pulley, again it is equal to load upon effort. Now in this case, load is balanced by two tension T plus T. Once again you can see load is balanced by two tension. One is this, another is this, because both the tensions are acting in the upward direction. These two tension is balancing the load upward directions. That is why load is equal to two tensions, and then this is equal to 2T. Then effort has to overcome the force of tension. Here just see to it, effort has to overcome the force of tension. So effort is equal to T. Now the mechanical advantage that is equal to load upon effort. Load is equal to 2T and effort is equal to T. So T and T get cancelled. It is 2. So mechanical advantage that is equal to 2. So this type of pulley that is used or acts as a force multiplier. Acts as a force multiplier. If somebody has any doubt, you can go through the first video. So in this case, once again students, in this case the load which is acting vertically downward direction, that is balanced by two tensions in the upward direction. So load is balanced by two tension 2T and effort has to overcome the force of tension. So like this you can find the mechanical advantage. Now coming to next, that is velocity ratio. Velocity ratio that is equal to what? Displacement of efforts or the distance moved by the effort upon the distance moved by the load L. This is what velocity ratio is. Now students, Just see to it. When the effort is applied in the upward direction, in order to lift the load in the upward direction, what will happen? Here the rope will move downward direction, and here the rope will move or string will move in the upward direction. Now the distance moved by the string in this side, let that is D. So that much distance will be moved by the string in the upward direction. If the distance moved downward, that is D, and the same distance will be moved by the string in the upward direction, that is also D. So this is D. Means if the distance moved by this string is D, downward directions, so the distance moved by the efforts will also be D in the upward directions. So the distance moved by the effort, that will be equal to what? If the distance moved that is 2D, distance of effort, because D from this side and D from this side. So D plus D, 2D. Now what happens? Now this, when the effort is applied upward direction, this load will be lifting up in the upward directions. Now what happens? This load will move half of the distance moved by the efforts, displacement of efforts. Once again, students, so once again, when this free end of a string is pulled up by the effort through a distance D, the load is raised up through a distance D by half, 2. Means the load raised up through a distance D, 2. Once again, students, you just do one thing. Once again, I'm going to explain to you. This topic is bit difficult to explain on the video, but even then I'm trying. Like, students, just see to it. If the distance move D in the upward directions, so this load will move half of the distance moved by the efforts. Or in other words, you can say that when the free end of the string, free end means this end, is pulled up by the efforts through a distance D, this load is raised up through a distance D by 2. Means if the distance moved by the string, that is D, the load will move half of the distance moved by the efforts. The reason is that the segment of this segment means this one, this segment of string on the both sides of the pulley moves up a distance D2. Means ye half, this will be also half. So D by 2 plus D by 2. So this is equal to what? This is D. If the distance moved, that is D by 2, and here the distance will also be moved by D by 2. So this is equal to displacement of effort, that will be equal to D, and the load will move by D by 2. Once again, the reason is that the segment of string on both the side of the pulley moves up a distance D2, that is D, and the DL will be equal to D2. So you can write here, this is equal to D, and the load, that is equal to D by 2. So this is equal to what? 2 into D by D. D and D get cancelled, and this is equal to 2. Even you can go through the content of this topic through the book, and if you will not able to understand, next time I will explain it to you. So once again student, distance of efforts, distance moved by the effort and distance moved by the load in case of single fixed pulley. So the velocity ratio is 2. Now coming to the next point, that is efficiency. Efficiency, that is mechanical advantage upon velocity ratio. So what is it? Is 2 upon 2. 2 and 2 get cancelled. It is 1, or you can take it 100%. So this is all about single movable pulley. Now the next is way to change the direction of the force. Next is this. I'm just going to write the topic: way to change the direction, way to change the direction of effort way to change the direction of effort using a movable pulley. Just see to it. This is an arrangement of fixed pulley. This is the fixed, just see to it, it is fixed. And this is a movable pulley. In other words, you can say this is an arrangement of fixed as well as movable pulley. So by taking these two pulleys, or more than one fixed and more than one movable pulley, we can change the direction of the effort. We can change the direction of the effort applied. Just see to it. This is load. It is again ideal case. Load is acting vertically downward direction. This movable pulley. This is movable pulley. It is fixed in the hook. The string is fixed in the hook, and then this inextensible string is passed over the fixed movable pulley as well as the fixed pulley. When the effort is applied in this direction, what happens? This load along with this pulley will move in the upward directions. So in this case, we can change the direction of the effort using a movable pulley. So by using this arrangement, it is possible for us to change the direction of effort. Otherwise, what will happen in case of this pulley, single movable pulley? Just see that it is bit inconvenient to apply effort in the upward direction. Just try to understand this diagram. Here we are applying the effort in the upward direction. It is bit inconvenient. So when we attach this pulley with this pulley, so we are able to change the direction of effort. So the next topic is the comparison between the single fixed pulley and the single movable pulley. Single fixed pulley means it is fixed to a rigid support, And single movable pulley means it is not fixed to a rigid support. Its mechanical advantage is 1, its mechanical advantage is 2. So you can go through it. This is also one of the important topic. So that's all for this topic. In the next video we shall discuss the next, that is combination of pulleys.